Hello viewers, in today's class we are going to solve one important integral involving greatest integer function, right? So let us evaluate this integral from square root of 2 to 2 log of greatest integer x square minus 1 dx, right? So here we have the function greatest integer function, right? So let us start. So here let us call this integral as I, and in order to evaluate this integral, let us make use of the method of substitution, and let us substitute t is equal to x square minus 1, right? So dt is equal to 2x dx, and from here x square is equal to t plus 1, so x is equal to square root of t plus 1, right? So here we have made use of the substitution method, and let us substitute t is equal to x square minus 1, so dt is equal to 2x dx, right? Okay, now dx can be written as dt over 2x, so dx can be expressed as dt over 2 times of square root of t plus 1, right? So the value of dx is dt over 2 times of square root of t plus 1. Okay, now let us change the limits, because here we have the limit from x is equal to square root of 2 to 2. So when x is square root of 2, then the value of t is given by square root of 2 square minus 1. So root 2 square minus 1, that is 2 minus 1, is equal to 1, right? Similarly, the upper limit is x is equal to 2, then the value of t is 2 square minus 1 is equal to 4 minus 1, that is 3, right? So when x varies from square root of 2 to 2, then t varies from 1 to 3, right? Okay, so now let us express this integral I in terms of t. So now we can write the integral from t is equal to 1 to 3, and here we have log of greatest integer x square minus 1. So for x square minus 1 we have t, so we have greatest integer t, and for dx we can write dt over 2 times square root of t plus 1, right? Okay, so now this can be written as half integral from 1 to 3 and log of greatest integer t over square root of t plus 1, right? Okay, now here we'll make use of the definition of greatest integer function, and we know that the value of greatest integer t is equal to 1 when t lies between 1 and 2, right? And similarly the value of this greatest integer t is 2 when t lies between 2 and 3, right? Why we are writing this? Because the limits are from t is equal to 1 to 3, and if we write the limits like this, here we have t is equal to 1, here we have t is equal to 3, so we have the integer 2 in between 1 and 3, right? So now we'll split this integral into the sum of two integrals. One is from 1 to 2 and other is from 2 to 3, right? So now this I can be written as integral half, and here we have the first integral from 1 to 2, that is t is equal to 1 to 2, and we have log of greatest integer t over square root of t plus 1 dt, plus the second integral is from t is equal to 2 to 3, and here we have log of greatest integer t divided by square root of t plus 1 dt, right? Okay, so what we have done so far, we have changed the variable x to t, and the limits from x is equal to square root of 2 to 2 to t is equal to 1 to 3, and between 1 and 3 we have the integer 2. So we have split this integral into two integrals. One is from 1 to 2 and other is from 2 to 3, right? So the value of greatest integer t is equal to 1 when t lies between 1 and 2, and the value of greatest integer t is 2 when t lies between 2 and 3, right? Now our aim is to evaluate these two integrals. So now viewers, I is equal to half, and here we have the integral from t is equal to 1 to 2, and here we have log of greatest integer t, and since the limits are from 1 to 2 and between 1 and 2 the value of greatest integer t is 1, so here we'll substitute 1, right? So here we have log of 1 divided by square root of t plus 1 dt, plus the second integral is from t is equal to 2 to 3, and the value of greatest integer t is equal to 2 when t lies between 2 and 3. So here we'll substitute for greatest integer t, we can write 2. Okay, so now we have log of 2 and divided by square root of t plus 1 and dt. Okay, so now here we have half, and the value of log 1 is 0, so this integral is 0. The value of this integral is 0 because log of 1 is equal to 0, and here we have log 2. We have taken this log 2 outside this integral, and integral from 2 to 3, and square root of 1 over square root of t plus 1 can be written as t plus 1 raised to minus half dt, right? So now to evaluate this integral, we can write t plus 1 is equal to y, so dy is equal to dt, and when t is 2, then the value of y is 2 plus 1 3. When t is 3, then the value of y is 3 plus 1 4, right? So now I can be written as half log 2, and the integral from 2 to 3 is now from y is equal to 3 to 4, and for t plus 1 we have y and raised to minus half dy, right? So this can further be written as half log 2, and the integral of y raised to minus half is y raised to minus half plus 1 divided by minus half plus 1, and the limits are from 3 to 4, right? So now I can further be simplified as half log 2, and here we have y raised to half and half. The limits are from 3 to 4, so this is half log 2 times 2 square root of 2 times the square root of y, and the limits are from 3 to 4, right? Now we can simply substitute the limits and we'll take the difference. So here we have half log 2, and taking this 2 outside, so we have a square root of 4 minus square root of 3, right? So 2 and 2 get cancelled, so we have log 2 times square root of 4 is 2, and here we have minus square root of 3, right? So the value of this integral I is equal to 2 minus square root of 3 times log of 2, right? So this is how we solve this problem.